Recording. Okay, good. All right. So we just finished quiz number 7. And I think we're in the process as we're getting closer to the halfway semester break. You've got a couple things to recognize. First of all, there's an extra credit project, which is basically section 5.9. It's called the Cumulative Review. It's a review of the first 5 sections. All right, it is due November 28th. That's 2 weeks.
Okay.
That's due. It's an extra credit project, number 1. It's also part of the review for the midterm, which we're going to have on December 6th. And so be aware of that, 6th or 4th, whatever that Tuesday is. Okay, so that's something. Make sure that you recognize this is going to take a little while to do. It's not a 20-minute assignment, so that's why we're giving you 3 weeks notice, heads up, to begin to work on it. Okay? All right, so that's the first part. Question?
Do you know how much extra credit it's worth?
I do not, but I'll figure it out. Maybe it should be worth a point.
No problem.
Maybe. Unless I feel generous, I may give you 2 points. I don't know. I don't have any idea what it's going to be.
Okay.
All right. Okay. Now, so what we're working on for this week is section 5.7 and the review quiz for the end of the chapter. Okay. So then that's going to be 5.8. That's the review quiz, and then 5.9 is that cumulative. For chapters 1 through 5, which is not going to be due, that is going to be due on November 28th. That's 2 weeks. Okay, so don't get that confused. So 5.7, and we've got a handout. That's what we're going to talk about 5.7 this week, and then 5.8 is starting to do the review problems. Okay. All right. Question on that? All right. So don't forget the extra credit projects here again. That's all right. Now, where I want to start with you is on a concept issue. All right, this is a parabola or a quadratic. Because a quadratic has to do with x squared. All right, and in the parabola, and it could be flipped upside down. All right, but in the parabola, the axis of symmetry that makes the 2 equal sides goes through the vertex. Okay, now you're supposed to know how to find the x value of the vertex given the quadratic equation. Okay, how many of you know what that is? The x value of the vertex is what? Negative b over 2a. Okay, you've got to know that. That's the whole key to be putting those things together. Now, what we've done in the past is, if you remember, we've also done completing the square. Right? If you have x squared plus some value x, all right, you complete the square by taking half of the second term and making that the binomial square. Right? So let's say you had x squared plus 8x. What's half of 8x? 4x. So parentheses, x plus or minus 4 would be the square. That would be your binomial square. And so the value of the x term will be 4. Right, now you could get it directly off of the quadratic formula by going negative b over 2a. Okay, but if you had to complete the square to get it, you could also do the same thing. You take half the second term when you've got the x to a value of 1. Okay. Now, one of the other things that the author of this book does, says, if I give you this point, because this is a line of symmetry, if I give you this point, you know that point.
I can't do that. I don't understand.
Okay, all right, okay, now let's watch. Let's watch. Okay, this point right here has a y value that comes up this high, right? All right, the x value is so many units away from here. So let's say, just for argument, let's say that this is 4 units long. Then how long is this?
4 units.
4 units. All right? Now, if this is at -2, what's negative 2 plus 4? That's going to be 2, whatever that y value is. Now, but if I go from negative 2, if I go this way, I'm at negative 6, whatever the y value is. Okay? So, now suppose this is a 2. Then if this is negative 2, this is 0, and actually my y value would have been right there. That would have been the y-axis, based on the problem I've got. Right? But if this is 0 at some value y, this is negative 2 at some value y, what will this be? Negative 4 at some value y.
It makes sense when you do it.
Does it make sense? Okay. And so all you're doing is that you're finding the change in the change in x that goes from the axis of symmetry, which is negative b over 2a, to the point that was given, and you're going in the opposite direction. So if it's 4 units this way, you're going to go 4, you're going to subtract 4, or go down 4 from this number.
Should make so much sense.
Okay? All right. And part of it is you ask the question until it makes sense.
Yes.
I'm serious. Ask the question until it makes sense. Okay, so let's try a different one here. Let's say that my axis of symmetry is x equals 5. All right, and let's say that this point right here is 8, 7. What's this point?
Negative.
Okay, now let's start. What's the first thing that you do know? That this distance is 5, and therefore this distance has to be 5. Okay, so subtract. No, I'm sorry, it's not 5, it's 3.
Oh, yeah.
My
I was
bad,
going to say,
my
I was
bad.
like, wait, when did he
My bad.
leave?
Yeah, my bad. I was already subtracted from the 5.
Right.
Okay, and so if I add 5, I'm at 8. If I subtract 5, I'm at,
-2.
not negative, in this case, it'd still be positive 2.
Oh, yes, sorry.
And the y value is still 7 because it didn't change.
Okay. But it's on negative signs, doesn't it?
No, that means subtract 5, take 5, subtract 3.
Oh,
Okay, now, had I done this, had this been 8, now, then this would be 13,
And the other one would be
and this would be
-3.
negative 3.
Negative. I was right the first time.
Right? See that? All right, so it depends on how far the axis of symmetry is from that point.
Right.
Okay? All right, now, okay, so that's the one skill. That was a skill from 2 weeks ago, which I didn't stress at the time. And now, this week, we are looking at if we have points on this graph, can we find the equation of the parabola?
Yes.
That's our question. And I hope the answer is yay and verily. Okay? So what we're going to do is that if we're given 3 points, doesn't matter where they are, we're going to use ax squared plus bx plus c equals y. And we're going to create a matrix, and then we're going to solve the matrix. Okay? So, let's see if I can get this up. Alright, so suppose that this is the information. Now, this is problem 2 on today's homework.
Perfect.
So we're going to work it. Alright, this is on page 210. 210. Okay. All right, now, 210 is talking about the amount of water left in the bathtub. Okay, and so you pull the plug, and what they've said is that the draining of the water because of pressure will be a quadratic function. And after 1 minute of draining, you had 38.4, that's probably liters. Yeah, 38.4 liters in the tub. After 2 minutes of draining, you had 21.6, and after 3 minutes of draining, you had 9.6 liters left. Okay, so you get the idea that the tub is going down, and it is a quadratic function you're given. All right, now, if you remember to create the quadratic function, this is a word problem, right? And word problems are so much different from regular problems that they're impossible to do. Not, okay? All right, the section that we're working on is given 3 points of a quadratic function. What is the equation? That's the first thing you have to do. All right, and we just spent an entire section before this section where you were given the points. Now, in this problem, you're given the points. Only they're in a sentence form instead of in a point form. Right? And it said, it gave you these 3 numbers, and then it said after 1, 2, and 3 minutes, respectively. All right? And so you've got to be smart enough, and you are, you've got to be smart enough to figure out what are the points. Once you get the 3 points, that's the problem from the previous chapter, which we all can do, provided that we don't make a silly mistake. Okay, so the first thing happens when this is squared, x squared. If x squared is 1, that makes a times 1. Then this is x, right? bx, so x is 1, this becomes 1, and there's always 1c, this is what's nice about it, equals 38.4, the y value. Now, 2 squared is 4, so that becomes 4a. This is 2 times b, which is 2b, 1c, and then 21.6. All right, what's the last one going to be? It's going to be 3 what? 3x squared. Right? And x squared, so what's 3 times 3? 9. So it's 9a plus 3b plus 1c equals the 9.6. All right, and now we have to set up a matrix and set up matrix C, and we have to solve it.
Yay.
Okay? So, we've got it started. Alright, and this is the matrix form. What do I want to do with these 2 ones?
Turn them into zeros.
I got to turn them into zeros. Okay? So now let's look. Let's look. If I take this number and subtract this number and put it in line 2, I'll have positives here and a negative there. I'd rather work with the positives on this side, personally. Right? So what I'm going to do is I'm going to copy that first line, and then I'm going to say 4 minus 1 is 3. 2 minus 1 is 1. And then 1 minus 1 is 0. And then 21.6 minus that is going to be 8, 6, 16.8, is that right? Somebody do that in calculator, please. 21.6 minus 38. Did I do it right? My head's not clear today. Got too much meds. 21.6 minus 38.4. Because this is a computer program, and I wanted us to do this. Is that your question? Why these are blank? All right, see, all I did was I copied this, I made those 2 red, and in order to be able to get that, we have to do this.
21, oh, is it negative 21.6 or is it?
It's 21.6 minus 38.4.
38.4.
I'm just asking, is that the right number?
So I was plugging up, yeah, 16.8. Yeah.
Okay, negative 16.8. Okay, now how do we do this next row? How do we get here? We're going to go 9 minus 1.
Right.
8, right? And then 3 minus 1 is 2. 1 minus 1 is 0. This minus this is again going to have an 8. And now I'm going to have 17 take away 9. This will be 28. Negative 28.8. Is that right?
20, it's just 28.8. 38.4
This minus,
Oh.
okay, yeah, it is, so it's negative.
Yes.
Negative 28.8, okay? All right, so now, now we have 2 zeros here. Now, if you're going to continue with the matrix C, you see the 1 right there? Doesn't need to be there? Because if you remember, our identity matrix is going to have a 1 here, a 1 here, and a 1 down here where the 8 is, and then zeros on either side.
Right. Right.
All right? So, if I leave this 1, I can take care of both this problem and this problem.
Right.
Right, I can take care, how would I get rid of this? 1. To make this a 0, I want to take this, subtract this, and put it up here. So this subtract this, put it up there. This subtract this, so the 1 stays there. Alright? So, when I take 1, 1, 1, and 38.4, that stays. Then I take this, subtract this. Oh, wait a minute, I'm sorry, I'm going on backwards here. I should have had the second one there. I'm keeping the 3, 1, 0, and negative 16.8. So then I take 1, subtract 3, get negative 2. 1, subtract 1, and get 0. 1, subtract 0, and get 1. This, subtract this, that means you're going to add.
38.4 plus
5.
negative, or just
All right, it's going to be this number, subtract this number, so it'll be 38 plus.
That equals 55.2.
So it equals plus 55.2. All right, now, how do I get rid of this 2?
Subtract it.
I have to multiply this row by negative 2 and then add it.
Okay.
All right, so negative 6 plus 8 is 2. Negative 2 plus 2 is 0. 0 plus 0 is still 0. And now put this in the calculator. Negative 2 times negative 16.8 plus 28.8. Put that in your calculator.
I got 62.4.
All right, this will be plus 32 and another 30, I'll take that. Plus 64 point, what?
62.4.
62.4. All right, you got that? Okay, now, how close are we to finishing this?
Pretty close.
All right, if you'll notice, if I divide this last row by 2, I get 1a is 31.4. Okay, so that's 31.4 x squared. Right? I've still got to do work to get rid of this 3, and I've still got to do work to get rid of this 2. But that's how the problem works. Okay, now we're not going to finish it out, but I want to just show you that's how you start those problems. All right, questions on this one? Okay, now what's important? What's important is, because of the way that this is given, we're going to do our identity matrix going backwards diagonal. And now you could do it forwards if you're happy. I saw somebody that did do it forwards. There's no problem with that. But if this number is a 1, that works. If it's not a 1, this always works.
Right.
Okay? All right, questions? All right, now let's look. All right, there's some questions I didn't let you answer, did I? Okay. All right, so now let's look. So that was problem number 2. All right, let's look at problem 4. Well, I erase this. All right. Now, problem number 4 says the number of cents per kilometer it costs to drive a car depends on how fast you drive it. At a low speed, the cost is high because the engine operates inefficiently. While the high speed, the cost is high because the engine must overcome high wind resistance. All right, therefore, if it's high when it's low and it's high when it's high, it's going to be a parabola. Okay, now, here's what it says, A. Suppose that it costs 28, 21, and 16 cents per kilometer to drive 10, 20, and 30 kilometers per hour. Okay, can you get 3 points from that?
Yes, you can.
What are they?
Would it be 10, 28, 20, 21, and 30, 16?
Okay, I think the Y is going to be 10.
Okay, the Y is 10.
Let's see. Wait a minute, I'm sorry, no, cost. The cost is going to be, so it'll be 10, 28, you were right.
Okay, cool.
10, because the cost is Y, and so 10, 28, and then 20, 21, and 30, 16. Okay? And now you're ready to set up your matrix. Okay, what do you have to do for the matrix? All right, now again, we are working with ax squared plus bx plus c equals y. Okay, now, what is the x in the first one? So 10 squared is 100. So I have 100a plus, then I have 10b plus 1c equals how much?
28.
The y, 28. All right, second row. All right, Ruben, what am I going to do for second row?
200.
All right, except, no, 2 times 2. 400. 20 times 20, not 20 times 10. Yeah, okay, 400 plus what? 20 plus 1 equals 21. All right, Aria, last one.
600.
No, 3 times 3.
Sorry, 900.
900, okay. 900 plus
20. 30. Sorry.
30,
Sorry.
yeah, plus 30.
1
1
and 16.
and 16, and then your starting matrix. Okay, now, these numbers are going to be ugly, and aren't you glad you have a calculator?
Yes.
Okay, all right. So, and again, we're going to start with 400, subtract 100, which will be 300 in the second row. And then 20 subtract 10, which is 10. 1 subtract 1, which is 0. And then 21 subtract 28, negative 7. Make sure you get the signs right. Okay, what will be the row underneath that? All right, you'll start with this
Subtract the first one.
and subtract the first one. So that'll be 800. And then I'll take
20.
and subtract that and get 20. And then 1 subtract 1 is 0. And now 16 subtract this. Looks like it's going to be negative 12, right? Okay, and then the first row is still the same. Okay, now what do you see from there? See anything imaginative? I can see dividing everything here by 2. Yeah, I could divide it by 4, right? Yeah, you could divide it by 4. All right, and so we could simplify that. I can see 10 minus 10 to get a 0 up here. All right, and you can begin to work your way toward making your identity matrix. All right, now, which numbers do you do? Which numbers do you do first? That's the ones you see is the one you do first. Okay, and you may not see the same thing that somebody else sees. Right, but when you get done, you should have the same answer because everything that you do, you're supposed to do correctly. All right, it makes sense? All right, and there's more than one way to be able to attack the problem. All right, but I see dividing all of this, I would have divided it by 2 just so I had those 10s, which would have made my subtracting easier to be able to get the number that I wanted. Okay. Then the other thing, if you look at this, what happens if you divide all this by 10? What's 300 divided by 10? 30. 10 divided by 10. Negative 7 divided by 10. Negative 0.7. Right? So sometimes you have to do that. Right? We had a couple of examples in the last section that were part of homework from last week where you were forced to have to, on the very last term, take this number and divide it into the augmented number to be able to get a decimal value. Right now, Ruben likes to do that first. He doesn't care because he's doing all his work by calculator. There isn't a problem. I like to do whole numbers as long as I can. Right? If you don't make a mistake and he doesn't make a mistake, we're still going to end up with the same answer, right? Because every math he does, he's doing correctly. So if you divided all of this by 10 and hadn't ended up with a decimal there, when you subtract it later on, you're subtracting a decimal, but the calculator doesn't care. Right? So sometimes you wait to the end to divide, other times you may do it earlier if you see a good reason for it. Right? Make sense? Okay, yes?
Can't you go diagonally?
Yes, yes. That's what, the week you were out, that's what we talked about, is that you can go diagonally this way, because this is a 1 in essence, that would make sense, right? But these are all 1s. And so we always know that we can get these two zeros just by taking this number, subtract this, and put it back in number 2, this number, subtract this, and put it in number 3. And so what we're looking at is getting these two zeros, then get a 1 here and a 1 here. But what happens if I got a 1 here and a 1 there? Can I have the 1 here and the 1 there? Sure. Watch. Let's interpret that. All right. What's that matrix say? It says A equals 5, C equals 8, and...
So it just reverses the order.
Right,
like
and all I'd have to do would be to switch these two around, and I would have the technical value. Right? So if I had...
It would take much longer.
Sometimes it does, Ruben, and sometimes it doesn't. Okay, what's my values?
B equals -5, A equals 8, and C equals 0.
Okay, so if I'm working with the quadratic, I would have 8x squared minus 5x plus 0 equals 0. Because my C is 0 in that case. All right, the A was 8. So that gives me 8x squared. The B is -5, -5x. In this case, the C was 0, so it'd be plus 0 equals 0.
I love when I understand math.
Okay, isn't it fun? Listen, when you understand it, then the challenge is a little bit of math work. But when you don't understand it, everything's hard.
Yeah.
If you ever tried to teach a 3-year-old what 2 plus 2 was, you'll understand how hard it is. Okay. All right, now we are way ahead of schedule here. This is 8 after. Okay. All right, so, that's 6. All right, here's what I'd like you to do. Turn over to page 212. Turn over to page 212. Good. I like pitches. I like pitches. Okay, first of all, can you see the parabola for problem 5?
Yep.
Okay, what do you notice about the parabola?
Very large.
Yeah.
Well, it's long, right? So, but I'm noticing which way is it open?
Downwards.
It's down. What does that mean about the A value?
Negative.
It has to be negative. Okay, so that's one thing to recognize. The A is going to be negative. Do you see any points?
Yes.
How many points you give it?
1, 2, 3, 4.
4.
I don't see a
Three,
point on
sorry.
that by the plane, right?
Sorry, I
Okay, it looked like it was, but it's not.
Arrow.
So you're given 3 points. So here you have 3 points.
But
Right.
aren't you given the intercepts
Yeah,
too, like the y and x, like you get 0
That's
and then
what
minus?
I didn't see that it said that, did it?
Well, I mean, you could see that the y.
But I don't know what the scale is. You know what the scale is?
No. So.
All right, okay. But I know that I'm given some points. Because I see -2, a -2, 50. I see -1, 4, 10. And I see 3, 2, 50. So I've got 3 points, but you should know that the A value should be negative when you're done. Okay? All right, so look at 6. Football field is, a football is punted. It goes up into the air, reaches a maximum altitude, and then comes down. Okay? You see that? So again, that's going to be inverted. All right, I want to look at something with you on that. Because one of the things that you've got to understand about the parabola for trajectory of normal rise and fall. Okay? What happens in a quadratic is that the vertex ends up being the highest point of the graph. Okay? So let's think of it this way. It starts here, comes up here, and it ends here. This vertex is the highest point. What is this? This is the start, and so its elevation is usually 0. Right? And then this is the end when it hits the ground, whose elevation is 0. Okay? The vertex is located on what line?
The axis of symmetry.
The axis of symmetry. Okay, what does the axis of symmetry do? It divides this parabola into 2 parts. So, if you know, now watch, if you know this time,
You know the other one.
then how much is that time? This time and this time is the same. So if this starts at 0 and you find out what the vertex x is, you add that to it again and you're back at this time. So let's say, just for instance, let's say that this took 3 seconds. When did it hit the ground? If this is 3, that's 3. When did it hit the ground? 6 seconds. Right? So if you do negative b over 2a and find that it's 3 seconds to reach the vertex, it's 6 seconds to hit the ground, you put 6 in for x and you'll find out how long it took. Or you'll find out the total time is back at 0.
Wouldn't that mean it was falling down at the same speed?
Yes, and that's the thing. If it's parabolic, it's symmetrical. Right now, are they all symmetrical? Not really. But these things, that's the problem that you're working with. That it has to be symmetrical. Okay? All right, so let's look at the football. The number of seconds of elapsed time since the ball was punted and the number of feet above the ground. Okay? Now, it says when the ball was kicked, it was 4 feet above the ground to start with. What does that mean?
Means they punted it.
That means right here, I don't think I need that. Right here, x was, or y was 4. Y is 4 instead of 0. I do have to turn that on. Come on. Man, what in the world? Okay. So here y is 4. All right, and then what else do you know? From problem 6. It was 24 feet above the ground 1 second later.
How does that even happen? Like,
Have you ever seen a football kick?
oh, yeah.
It just, boom, it's up in the air. Right? Okay. So we had 1 second later, it's how many feet?
28.
28 feet. Okay. And what else does it give you?
2 seconds after it was kicked, it was 20 feet up.
2 seconds later,
Dropped it 8.
it was 20 feet. Okay, now, so what does that mean? It's already past the vertex, it started back down. Okay, and do we have a third point?
No.
Yeah, well, we do.
We do?
We do.
0, 4.
Oh,
Yes, we do. We have one.
So we have our 3 points.
Right.
Okay, so now you can set up. You can set up the same type of matrix and find your A, B, and C, and that will give you, and you should know that the A is going to be negative because this is a motion parabola
Right.
looking like that, okay? All right, questions?
Sir.
All right, good. Now, let's talk about two of the problems from this quiz you just did. Except that somebody's not going to be here. Oh boy. All right, let's look at, I want to make sure that on this problem, okay, what's the first step? What's the first step you have to do on this problem to solve it?
You subtract 5x from both sides and then subtract 6 from both sides.
Okay, so negative 5x, and then minus 6. Minus 6 gives me 7x squared plus 3x is not working, running out of pen.
19.
Okay, so then you're going to put negative 3 plus or minus the square root of 9 minus 4 times 7 times that, and it's not going to be,
Yeah, it's negative.
It's negative 523.
523.
it's going to be a negative number, so you're going to have an I.
Yep.
Oh,
Yep.
okay.
Okay. Now, one of the things that you look for is that we like to see a negative number here,
Right.
because negative 4 times a negative c will mean you're adding the numbers underneath.
Right.
If not, this number here has got to be sufficiently large enough to be able to handle these two numbers times 4.
Right.
See, like had this been, say a 33, then you would have had 33 squared minus 4 times 7 times 19, and when you subtracted that, you would still have a positive value. All right, but in this case, it's not. Now, what does the original problem, what does this mean? If I get an imaginary number,
Can't actually happen.
that means it can't touch the x-axis.
Right.
Yes,
Yeah.
it can't touch the x-axis, so it's up here somewhere. Where's the vertex?
Is it at?
Well, where's the vertex at? What are the letters? Negative b over
2a.
2a. So negative 3 over 20 over 14. Right? Negative 3 over 14. Right? 3 over 14 is roughly 1/4.
Right.
Right? So that means that the vertex is lying at negative approximately, well, let's put it this way, negative 3 over 14. Right? That's your line of symmetry. Okay? And so that means, now, if you have a 0 here, a 0 here, you have plus 19. Right? That means the other one's right here. Because remember, these two are the same distance from the vertex, or from the line of symmetry. All right? And so that means you're probably going to be like this. All right? And as Clarissa said it's impossible for it to have a solution because it's graphed way up high.
Right.
Unless that's negative. And if that's a negative, then this thing would come down this way and it would have a solution.
Right.
Because remember, it's negative 4 times AC, right? And so if this 7 is negative, you'll have negative 4 times negative 7, which is plus. And then it would have a solution because the negative would flip this down and come opening down. All right, does that make sense? Okay, so the word problems. My goal today was to show you that the word problems are no worse than the problems in the previous chapter.
Right.
Now, the problems in the previous chapter weren't simple. Right? Doing a 3 by 3 or a 4 by 3 matrix is tough because if you make a mistake or you don't see what to do to be able to get the identity matrix, it can be really difficult. Right? But the word problems are no worse because unless they give you the 3 points, you can't find the equation anyway. Right? And later on what they're going to do, they're going to give you the equation and they're going to ask you things about it. That's where you're going to get into the fact that the line of symmetry separates, and if they have this one, when you have this, the line of symmetry tells you that the distance here to the peak and the distance to where it gets back to the ground again are the same. So you're going to take 2 times negative b over 2a. All right? Okay, good day today. We're going a little bit short, but that's okay because we've gone along before. All right? Good day.
Thank you, Mr.
Sorry, 10 minutes.